Hi, my name is Mackenzie. I'm a software engineer and I'm here to talk to you about AI. It looks like Takeoff has been achieved and there's some leaks that are coming out of OpenAI that we can talk about to discuss OpenAI's method that they think they can use to achieve artificial superintelligence. So I have prepared a little Figma for you to understand the method that they're using to get this done. So this is user Gwern, 18 hours before the screenshot was taken, which was recently in the last couple of hours on January 16th, 2025. It says, I think this is missing a major piece of the self-play scaling paradigm. Much of the point of a model like O1 is not to deploy it, but to generate training data for the next model. Every problem that an O1 solves now is a training data point for an O3. For example, any O1 session which finally stumbles into the right answer can be refined to drop the dead ends and produce a clean transcript to chain a more refined intuition. This means that the scaling paradigm here may wind up looking a lot like the current train time paradigm. Lots of big data scientists laboring to train a final frontier model of the highest intelligence, which will usually be used in a low search way and can be turned into smaller, cheaper models for the use cases where low/no search is still overkill. Inside those big data centers, the workload may be almost entirely search related, as the actual fine tuning is so cheap and easy compared to the rollouts. But that doesn't matter to everyone else. As before, what you see is basically high-end GPUs and megawatts of electricity go in, you wait for 3 to 6 months, and a smarter AI comes out. I'm actually mildly surprised OpenAI has bothered to deploy O1 Pro at all instead of keeping it private and investing the compute into more bootstrapping of O3 training, etc. This is apparently what happened with Anthropic and Claude 3.6 Opus. It didn't fail, they just chose to keep it private and distill it down to a small, cheap, but strangely smart Claude 3.6 Sonnet. If you're wondering why OpenAIers are suddenly weirdly, almost euphorically optimistic on Twitter, watching the improvement from the original 4.0 model to O3 and wherever it is now, maybe why. It's like watching the AlphaGo ELO curves. It just keeps going up and up and up. There may be a sense that they've broken out and have finally crossed the last threshold of criticality from merely cutting-edge AI work, which everyone else will replicate in a few years, to Takeoff, cracked intelligence to the point of being recursively self-improving, and where O4 or O5 will be able to automate AI research and development and finish off the rest. Altman, in November 2024, saying, I could see a path where the work we are doing just keeps compounding and the rate of progress we made over the last 3 years continues for the next 3 or 6 or 9 or whatever, turns into a week ago. We are now confident we know how to build AGI as we have traditionally understood it. We are beginning to turn our aim beyond that to superintelligence in the true sense of the word. We love our current products, but we are here for the glorious future. With superintelligence, we can do anything else. Let DeepSeek chase their taillights. They can't get the big iron they need to compete when superintelligence research can pay for itself, quite literally. And then you get to have your cake and eat it too. The final AlphaGo Zero model is not just superhuman, but very cheap to run too. Just searching out a few plies gets you to superhuman strength. Even the forward pass alone is around pro-human strength. Okay, so what is this saying? What does this mean? I have like a little bit of art here on the side. Where were you during Takeoff? Just that's fun. But I have some things in here that we can reveal. On how this all works and what this person is talking about. So, when you're using a model like O1, which uses something called test time compute, okay? So that means you ask it a question. There's an original question that you posit to the model, and then it spends a lot of electricity, a lot of time, thinking through different answers, comparing and contrasting and generating thoughts. And then at the end, before the final pass, all of this information, the original question, all of the input data, all of the context, plus the entire chain of thoughts, this all gets grouped up, right? Draw a box around it. This all gets grouped up and it's used to generate an answer. This gets fed forward to produce the final answer of the system. And typically, given all of this context, all of this electricity that went into producing thoughts and additional context in order to answer the question, leads to the answer being a lot more intelligent. But a quirk of artificial intelligence is that you don't have to do it this way every time. Every time you want to answer a question, you don't have to go through all of the electricity to compute this to get to the answer. You can distill, right? You can have a system that looks a little bit more like this, where there's just the question and the answer, right? You just fine tune a model. You say, hey, these are questions. Here's are the well thought out, well reasoned, highly intuitive answers that we would expect to see for these questions. And they just kind of go together. And now that it's a really short hop from question to answer, we can actually do this process again, right? Like we can get better answers by taking this system and expanding it with more test time compute, right? So we don't know what the answer is, but this first answer, this from this layer, this can kind of be converted to the first thought in the chain. And then it's able to use that as context to continue to produce better, more intuitive, more well-reasoned thoughts. And all of this electricity can get distilled into the gaps here. And then finally, when we get to the answer at the end of this chain, we could just do this process again, right? We can, after we do all the test time compute to get all these thoughts out so that we get to an even more intelligent, even more well-reasoned answer, we can just distill this and then do the process again. So basically, we run into a system where it looks like from the outside, there's GPUs that are running inside of a server and there's lots of electricity, but the thing is that it's not processing the data, it's running electricity on generating synthetic data. The synthetic data produces better answers according to the questions that was originally posed. And this is an automatable process. We can just use the original test set to produce kind of a base level of questions, and then those questions create new questions, and we could put O1 to go and answer those questions, distill it like this, and then this becomes O3. O3, we can give the test time compute, and it'll do this, where we get even more intelligent, more well-reasoned answers, and then we could distill it, and then we have O4, and then, we do it again. We just keep scaling this test time compute. And importantly, with a system like this, at the end of the day, we get a distilled model, a smaller model that just matches the questions to the answers, right? We can skip over all of the electricity. So that means that the final model at the end of the day is going to be super intelligent, but distilled. It's going to be small and cheap, and we can have super intelligence kind of deployed on small devices and with low power due to this kind of like distillation factor. So that's what Gordon is saying here. That's what people are getting excited about as far as Takeoff goes, because we have this kind of magic ability in order to distill models. The only thing that we really have to scale is the test time compute at this point in time. The test time compute can scale, then we can distill it, then we can scale that and then distill it and then scale that and distill it. And it's kind of like back and forth. That's happening at places like OpenAI and Anthropic has got the AI researchers very excited. That's what Quern's claim is here. And yeah, this might be Takeoff. This might be a method for us to recursively kind of produce superintelligence. And the answers that come out, humans might not know if these answers are correct or not, but we might be able to use them to fund or direct research in order to do some of the engineering problems to break through some of the other things that we're trying to scale here. Right? Enough of these kind of distillations of the test time compute can get us through like breakthroughs in things like gene editing and material science and so on and so forth in order to get better, AI researchers, right? Smarter, more energetic people, or it could solve the material science to get better chips for AI to run on, or it could solve energy science to get more electricity for this kind of scaling to happen, right? Like the answers that come out, they're not just like toy problems. Like these can be real scientific questions that we're trying to find answers to, and then industry can use this in order to like continue this scaling through. Because again, the thing that we're scaling here, it's not a chess playing robot. This is, a thinking machine that's able to solve important problems. And so making a thinking machine that's better at solving problems allows it to solve, more problems, because that's what it says on the tin. So yeah, this is all very exciting, and that this may be artificial superintelligence Takeoff. So that's enjoyable. Follow this channel if you want to see more about implementing this artificial superintelligence as it comes out. Just to check your knowledge on kind of programming and stuff like that, and implementing these things. If you need help implementing AI, feel free to reach out. And yeah, that's it for today's video. I will talk to you later.